Yo, what's up guys? So moving on to the next example for the synthetic division of polynomials. We got 4x cubed minus 8x plus 3, and we're dividing it by x plus 2. Now this example is the same as one of the previous examples that we did for the long division of polynomials. And the reason why I'm doing that is because I think it's valuable to see how both methods, long division and synthetic division, you end up having the same result. So I'll put a link in the description box of the same long division example that we did so you can compare both methods. So let's do synthetic division on this problem. So the first thing you always check with synthetic division is the divisor linear? And it is linear. X plus 2 is a line, has a degree of 1. Next thing we check is, does it take the form of x minus k or ax minus b? Well, if you notice, it doesn't take the form of x minus k. It's x plus a number. However, if we take this divisor and kind of manipulate it, so what if we write something like x minus negative 2? Well, that's the same as x plus 2. I just took this plus and I made it into two negatives. And now it's in the form of x minus k, and our k value is negative 2. So that's one of the tricks with this question, is whenever you get a divisor with synthetic division that's x plus a constant, always change it to x minus negative of that constant, so it's in the form x minus k, and then your k value is whatever that negative a is. In this case, it's negative 2. Now, the next thing that applies here, we did this in the long division example, is notice how there's an x squared missing here. So we have to rewrite the dividend, but for that x squared term, remember we put a leading coefficient of 0. And it's actually more critical to put these 0 leading coefficients for any terms that are missing for synthetic division, even more so than long division, because the vertical algebra really matters. So 4x cubed plus 0x squared minus 8x plus 3, and we're still dividing it by x plus 2. So now we can make our chart. We have everything that we need. So the first thing we do is we take our k value, put it up here. So our k value in this case is negative 2. Then in the first row, we rewrite our leading coefficients of the dividend, including the 0 that we included. So 4, 0, negative 8, and then positive 3. Now, what's the first step always? We just bring the 4 down as it is. So we would have 4 here. And then what's the next step? We take this 4 and we multiply it by whatever our k value is. In this case, it's negative 2. So 4 times negative 2, that gives us negative 8. And then we just add this column here. So 0 plus negative 8, well, that just gives us negative 8. And then same thing applies. We take this negative 8, multiply it by our k value of negative 2. So negative 8 times negative 2, that gives us positive 16. Then add this column here. So negative 8 plus 16, that gives us 8. Then we take the 8, multiply it by negative 2 again. Our k value of negative 2. So 8 times negative 2 gives us negative 16. And then adding this column here, 3 plus negative 16, that gives us negative 13. So what do all of these numbers here represent that we got? Well, remember the last number is going to be the remainder. And these numbers here are the leading coefficients of quotient. So if you notice, the degree of our dividend was 3, the degree of our divisor was 1, So the difference between those degrees is 2, and that gives us the degree of our quotient. So we know our quotient is going to have a degree of 2, and it's going to have these leading coefficients. So our final answer, the quotient, is 4x squared minus 8x plus a constant of 8. And our remainder is negative 13. And if you look back to the example that we did for long division, the same example that we did, we got the same result. And then writing this example in a division statement, we got our dividend of 4x cubed minus 8x plus 3 is equal to our divisor of x plus 2 times our quotient of 4x squared minus 8x plus 8 minus our remainder 13. In the next video, I'm going to go over synthetic division again. However, we're finally going to deal with the ax minus b case, and it's a little bit more complex and the process is a little different, so make sure you go and watch that.